Welcome to the Using Node.js video series from MarkLogic University. This video is the fourth part in a series of topics covering the use of the MarkLogic Node.js Client API. In this video, we're going to be focusing in on search. At the end of this video, you'll be able to describe security requirements for performing search, perform query by example or QBE searches, perform string query searches, and perform structured query searches. We'll also take a look at creating a field and using that in our search. To follow along with this tutorial, you'll need to install the software prerequisites including MarkLogic and Node.js. As we progress throughout this tutorial, we'll refer to various pieces of code. These examples are available through the MarkLogic University GitHub site. Now think back to episode 2 of this series when we discussed performing inserts and reads. Remember that when writing documents to the database, you can manage permission metadata on those documents. Those permissions will govern your ability to search the database. When performing a search, you are only searching the documents that you have a read permission on. In this tutorial, we have been taking advantage of the out-of-the-box roles for working with the REST API, specifically the roles called REST Reader, REST Writer, and REST Admin. In order to perform searches, your database client needs to authenticate as a user with the REST Reader role or a custom equivalent. Now back in episode 2 of this series, we created project-specific users and associated those users with these default REST roles. We'll continue to use those same users for the examples in this tutorial. Next, let's take a look at the general approach to search in MarkLogic. Anytime you're building a search, you're going to define three things. First, what are you looking for? For example, are you looking for documents that contain the words cat or dog but not fish? Second, what do you want back? This is your results set. How many results do you want? In what order should they be returned? Do you want specific data to come back from the matching documents? And third, once all the criteria have been defined, you'll actually execute the search and work with the response data. Using MarkLogic, there are several ways to search the database. Query by example, or QBE for short, enables you to define a pattern or prototype document and go out and find other documents that match that pattern. Imagine you've just prepared an amazing dessert that you found in our recipes database. You might want to go out and search for other recipes in the database that contain similar ingredients or use the same cooking techniques or equipment. You could do this by using components of the recipe that you really enjoyed as your template. String query is another way to search the database. This is classic Google-like search grammar that users are generally familiar with. Simply enter your query as a string, grammar and all, and pass it off to MarkLogic. The grammar is automatically known and understood, and you can provide custom grammar as well. And finally, MarkLogic supports structured query. Think of structured query like the advanced search pages you see on some websites. Here you can enter multiple criteria to define very specifically what it is that you desire back. In MarkLogic, these can be some very expressive queries. For example, find me trade documents that contain the words risk or compliance but not liability, where the amount of the trade was greater than £100,000, and the trade was executed in the first quarter of 2016 by a trader based in the United Kingdom. This is a very specific query, and it includes full text, range, and geospatial search components. In MarkLogic, unlike some other NoSQL databases, you can enter multiple criteria and combine multiple indexes to define very specifically what it is that you desire. Now let's take a look at how to build searches in our Node.js applications. First, you'll need to create a query builder instance, and you'll also need your database clients. Remember that to search the database, you need to have read permissions on the documents that you wish to search. so we'll use our dbRead client in these examples. Let's assume that this code is in place for the next few examples that we'll study. In this example, let's imagine that we have a database containing information about various types of media, such as music, movies, and books. And let's say that you found a song that you really liked, and so you'd like to go out and find others that would be similar. This is a classic use of QBE. In this example, we see a variable called QBEDoc, and that's defining the pattern or the prototype that we're going to go out and try to match. And this specific pattern is defining that we're looking for artist properties that contain the Beatles, genre properties that are equal to rock, writer properties that contain the word Lennon, and album properties that are equal to Let It Be. To execute the search, you would use your dbclient.documents.query and use your query builder instance to define the search criteria and the results set. Here, the search criteria is defined to perform a QBE looking for other docs that match the example defined in our variable. The result set is defined and uses slice to say that we want to bring back the top 5 relevant matches, and we also want to bring back some specific data from those matches, including the artist and title properties. Next, let's take a look at QBE in action against our database that we've been building throughout this series. So just like in prior episodes, the first thing that we'll do to get a new project up and running is navigate through the command prompt to our project directory and do an npm install, and this will install all the defined dependencies within this project's package.json file. Now that we've set up our new project, we're going to want to load some data in order to make our searches more interesting. So we'll continue with the theme that we've been building on in this series, where we're loading recipe documents. And to load some new recipe documents, we'll simply run node load.js, and this will load some sample documents for us to work with. And if we then go and take a look inside of our database, we can see that we've now got roughly 10 documents that we can work with to be able to do some of these searches. Now that we've loaded some data, let's take a look at our first example, QBE.js. Here we see some of the basic stuff. We see the import of our MarkLogic API and our connections module, which defines all of our connections for working with our database. And we see the definition of our dbRead client, and this will allow us to search all the documents which we have read permissions on. And again, because this database client is created with a user that has the REST reader role assigned, any documents that were loaded using the API with default permissions set will be able to be read, in which case all the documents that we just loaded when we ran load.js will fit that bill, and we'll be able to search those documents. Next, we see the definition of our query builder. And then we see the definition of our prototype document, the variable QBEDoc, where here we're seeing that we're looking within the name property for documents that have a name property containing the word pie. We're looking in the ingredients property for documents that contain the ingredient butter. And we're looking in the preparation property for documents that contain the word baking. We use our database client.documents.query to define our QBE, and then to define the slice of data that we wish returned, in this case, the 5 most relevant documents. And then we use the promise result handler to work with those results and return the matching documents. So let's go ahead and run this example to see what we get. And if we look at the response that comes back to us, you'll see that we get our document for apple pie. And this makes sense because if we look up here in the name, we see apple pie, so it contains the word pie. If we look in the ingredients, we see that it contains the word butter. And if we look at the preparation instructions, we see that it has a reference to baking. However, if you look really closely here, you'll notice that the word baking doesn't actually appear in the results. However, the word bake does appear. This is a concept in MarkLogic search and indexing known as stemming, where we stem words to their native root based on the language defined. In this case, in English, the word baking has a stem of bake. So when you do a search looking for documents that contain the word baking, they will match documents that also have the word bake inside of them. However, if you look at some of our other documents in the database, one of the things that you'll notice is that we also have a document here for mushroom pie. And if we were to go out to Query Console and look at the contents of that document, we see a few things. Notice we see a title property, and it contains the word pie. We see the ingredient property, and it contains butter. And in our preparation instructions, we also see the word bake. So why wasn't this document a match? Well, think back to our actual query and look at this document again. Note title property, the title is mushroom pie. But if we go back and look at our query, we're not looking within the title property. We're looking within the name property. And that's why mushroom pie is not a match. Now, this is a common situation when you have documents coming into your system from a variety of different sources. They might not all be structured and described in the exact same way. And in MarkLogic, with our schema agnostic approach, that's okay. We'll show you a little bit later about how we can implement something called a field to help unite what is logically the same thing across many different document types. Next, let's take a look at some examples of string query against our hypothetical media database. This example is as simple as it gets. Our search criteria is to look for documents that contain the word Coldplay anywhere in the document. The result set that we define is to bring back the 5 most relevant matches. And then we execute this using the promise result handler. Next, let's take a look at a slightly more complex example that shows the ability to implement a custom grammar inside of MarkLogic. Notice the query that the user is entering now, art:\Coldplay. This is different than simply entering the term Coldplay, because in our application, we are assigning meaning to the piece of grammar called art. And we can see that defined here in our querybuilder.parseBindings, where we're assigning a binding for the grammar art and binding it to a specific property in our document set. In this case, the artist property. Now, the difference between the string query in example 1, where we're simply looking for the term Coldplay, is that finding the term Coldplay can appear anywhere in the entire document and it would be considered a match. Versus example 2, now we are defining with our custom grammar that we're only looking for the term Coldplay in the artist property. Let's take a look at this in action against our recipes database. Let's start by taking a look at the code in string.js. First, we see some of the basic things like the importing of the MarkLogic API, the definition of our database client, and the definition of our query builder. Then we see the actual query itself. Now, imagine that this query is actually coming to us from a front end, and our middle tier application is going to process the data that's entered by a user in that front end and execute the search. And in this example, our query contains 2 terms and a piece of grammar, apple or banana. In MarkLogic, that grammar is automatically understood and we execute the appropriate OR query. Then we use our database client to execute the search, and we use our query builder .parsedFrom to take the string that was entered, parse it, and execute the query. We define the result set using slice to return the 5 most relevant results. Let's go ahead and run this and see what we get. And if we look at our results, we'll see that we're actually going to return two matching documents. The first one is our fruit salad document, and the second one is our apple pie document. And that makes sense because the apple pie document mentions apple, and the fruit salad document mentions banana. Now let's slightly modify this query just so you can see another example. So I'm going to go back to the code here. And again, remember that MarkLogic understands a Google-like search grammar. So maybe I don't have an oven at my disposal in order to bake a pie. So I want to say that I'm not interested in recipes that involve baking. So I simply add to this string query another piece of grammar and another term. And now I'm saying apple or banana, but not baking. Now let's go ahead and go back and execute this search one more time and see what we get as our results. And as expected, when we execute this the second time, we have eliminated the apple pie document from our results set, and we're left with our fruit salad result. Next, let's study an example of structured query against our hypothetical media database. Structured query is very expressive and very customizable. Take a moment to study this example. Go ahead and pause the video if you need some time. Think to yourself, what are we asking of our database in this example? In this example, we're defining our query to look for documents that are in the songs directory and have an artist property with the word Beatles in it, and have a genre property with a value equal to rock, and do not contain the word writer in the title property, and contain the term love or the term night somewhere in the document, and contain the term hard and the term day anywhere in the document, but they must be next to each other. In other words, within one position of each other. This is a very specific query, and there are many constructors available to you to construct even more complex queries integrating both full text, range, geospatial, and semantic search all together to be able to ask custom questions of your data. For more information on these query constructors, please be sure to check out the documentation. Now let's take a look at structured query in action against our recipes database. Let's start by taking a look at structured1.js. This example is really a more expressive version of the very first example that we ran, executing QBE. And if you think back to that QBE example, one of the things that we saw is that we were able to match our apple pie document but not our mushroom pie document, because those two recipes came from different sources and they had different structure. One had a title property and the other had a name property. This is going to address that with a more expressive structured query. The first component that we see here is a directory query, and this enables us to constrict which documents we're actually going to search against based on their URI. And in this example, we're only going to be searching documents whose URIs begin with /recipes/. Next, we see OR logic surrounding two word queries where we're looking for the word pie in either the title property or the name property. Then we see a value query. This is very specific. It says within a particular property, in this case the ingredients property, we must find a value equal to butter. The difference between a value and a word query is that a value query has to be an exact match to that property's value, whereas a word query simply says this word must appear within that property's value. And then last but not least, we see a word query within the preparation property looking for the word baking. Let's go ahead and execute this search and see what we get. And when we look at the search results, we will see that in fact we do get both of the documents back. We get the mushroom pie document and we get the apple pie document. Now think about how we used OR logic in that last example in order to search both the title and the name properties of our recipes. Now think about if you had thousands of different data sources. It might not be realistic to have OR grammar to integrate each one of those different variations across those data sources. And when using Mark Logic to integrate data from silos, it's common to have many sources of information, and they don't always describe entities in the same way. Think about our music example. What if we had data coming into our system from many different sources? Some may define artist or singer or group or band. These are all logically the same thing. Rather than incur the cost of trying to perform ETL processing in order to transform the data on ingest and get each source to look the same, instead, you could be tolerant of the differences and simply unite these data points together using a field, and then you could constrain your search against that field. Then, down the road, when you need to quickly integrate another data source that you're introducing into your system, you don't need to make any application code changes. Simply add the new property name to the existing field, and that data will get rolled up into the field. Fields are also extremely valuable because they enable you to define specific indexes that will only apply to the data in the field as opposed to the entire database. Think about how this could benefit you. What if you had an application requirement to be able to do wildcard searches against performer data? Creating a field and turning on the necessary wildcard indexes on that field would be a more efficient approach than simply turning on the wildcard indexes for the entire database. Now in this next exercise, we're going to create a field in order to unite the name and title properties in our recipe documents. Now there are many ways that you could go about creating a field. You could do it manually using the admin interface, or you could do it programmatically using the Management REST API or server-side JavaScript or server-side xQuery. Since this may be the first time that many of you have ever created a field, we're going to show you how to do this manually through the admin interface. So open up your admin interface on port 8001 and let's select the database Node Example Content. Next, we're going to scroll down through the database configuration settings and we're going to find Fields. Select Fields and then select the Create tab. Now the first thing that we'll need to do is give our field a name. And this can be anything that we wish to call it. We might choose something that's going to be logical to what this data represents. So let's call ours Recipe Title. And then we define the field type. And for us, we want to select properties off of the root directory. And so we're going to set this equal to root. Let's click OK to create that field. Next, we need to define which properties this field should include. So let's click on the Includes tab and let's specify our name property first. And remember, JSON properties don't have namespaces, so we can just leave that namespace field blank. And then let's specify a second include property, this time for the title property. And we click OK again. And now we have created our field, and we should be able to see this in the summary. We have our field called Recipe Title, and it includes the name and title property. So now let's go ahead and use this field that we just created in a search. Let's open structured2.js and take a look at the code. And here we see an example of structured query where we're using a directory query just like before, but now we see that we're using a field query where we're specifying the name of the field as recipe title and what we're looking for within that field, in this case, the word pie. This should then search across values of title properties and name properties looking for the presence of the word pie. And we're also doing a value query looking for an ingredient equal to butter, and a word query within preparation looking for the word baking. So let's go ahead and run this search and see what we get. And when we look at the results, we now see that we get matches for both our mushroom pie document and our apple pie document, because we have now united the name and title properties into our field called recipe title and constrained our search against that field. This concludes the search episode of the Using Node.js video series. In this episode, you learned about the security requirements for performing search. You learned how to perform QBE, string, and structured query searches, and you learned how to create a field. As a next step, make sure you go out and get MarkLogic as well as all the exercises that we discussed in this episode, and you can access additional training through our on-demand site or through our instructor-led or self-paced offerings. And finally, don't forget to show off your new skills. Add MarkLogic as a skill to your LinkedIn profile today.